Hello everyone, my name is Mojtaba. Welcome to my presentation about the importance of reproducible research in computational sciences by showing a use case for uncertainty quantification. Reproducible research has become the crucial aspect of open science in recent years. The core idea of reproducibility is that the results of every research work should be reproducible and replicable by everyone else given the original code, software, and dataset. In computational sciences, it becomes even more important because every researcher can claim a wide range of different outputs without providing enough details for the others to reproduce the results. That's why in this field, there is a common belief among the researchers that never believe anything unless you can run it. Reproducibility in computational sciences increases the authorship of the work by increasing the trust that people will put in the results, because they can grab the models and the code and rerun them to be sure that the reported results are indeed correct. The traditional way of making this possible is making the developed models and codes available as open source codes with open source licenses so people can grab the codes and models and run them. But the more modern approach, and indeed a better approach, is publishing the building blocks of the research in a producible manner. So people get to know the details, the internal techniques and methods that the researchers have employed in their work. This is where Jupyter comes into play. By definition, Jupyter is an interactive computing environment for running a wide variety of different programming languages in a unified environment. But in practice, it will provide an environment for a full representation of the building blocks that are enriched by extra description beside the codes. This will increase the transparency, and as was said, this is an important aspect of reproducibility, especially for the people who don't have a deep background of the topic. It will help them to increase their knowledge of the internal of the works. And it brings also another great bonus, that its interactive nature, we mean the interactive nature of Jupyter, will make it possible to convert the already prepared reproducible research works into really valuable educational materials. So people can hit two targets at the same time, yielding reproducibility while having educational materials of their works. As an example in this regard, we want to show you a use case of model parameter calibration. This process, model parameters calibration, is an inevitable aspect of computational research projects. In these kind of projects, the models come with a wide variety of different unknown parameters, the value of which cannot be obtained from experiments. As a result, we need an extra process to estimate these parameters. In this case, a practical implementation of this process is demonstrated. So in this process, in this optimization process, we have a search space of parameters out of which we want to obtain the most optimal values. So we start with an initial guess of parameters, and then through a relatively standard optimization process, we estimate these values by running the model several times and then trying to pick the best value for the next iteration. And then we go on. So this is indeed one of the building blocks of every, or let's say most of the research projects in computational sciences. Implementing this process in Jupyter notebooks will increase the reproducibility of the work, because it would help people to understand and run the process themselves. And at the same time, it will help them by guiding them through these steps one by one to adapt the content and use it in their own research. This implementation is freely available in a GitHub repository in the URL mentioned here. So in this presentation, I talked about the importance of reproducibility in computational sciences works, and the role that Jupyter plays in increasing transparency as one of the key aspects of reproducibility. And a use case was related to a model parameters calibration for showing the proof of concept. Thank you so much for your attention.